So, we've been many times asked by a performance group to actually be able to use perf on scripts, meaning that currently when you use the perf on the Python script, for example, what you will get as a sampling view, you will get the state of the interpreter, and what they want to see, actually sampling of the virtual state of the interpreted language, in this case the Python script. So, and also, I mean, for annotation changes, they want to see, like, now it's only possible to see C files and the compile code in that annotation. Basically, we want to be able to see the scripts and the annotations for the scripts. So basically, what we have prototyped so far and what we are testing now, basically there are two issues that we need to solve. First, you need to get the data from the interpreter to actually get together the virtual stack of the script, and then you need to somehow deliver it to the sample. And also you need some symbol details, because there's nothing like symbol tables inside of the script. So there's things that the interpreters can run, like the initial scripts that can act as a script agent. They call it in Python, I think. And you can hook all the debugging data, and you will get all the information about the lines being processed and about the functions being called. So this way we can actually get the virtual stack of the running script, and we can get also the symbol details. Then, so that's one issue solved. Basically, we have all the info that we need later on to actually translate the virtual stack data to some report information. But the sample itself for hardware events happens in the kernel, so we need to get this virtual information of the stack to the kernel. So what we do, we actually, for each process, we use PRCTL to map the data using the mmap call, and we set this data to be attached to each process. And whenever there is a sample, we take the data from this area, that we register using this PRCTL. So this way we get this virtual stack into the sample, and it will eventually get to the perf data, and we are able to display that. So that's one way. When I actually introduced this to Peter Zarstra, well, he said, if people want, I mean, if you want to run something fast, you don't put it to the script, so there's no reason to profile script, but we have a performance guys who actually want this. So basically this is how the prototype works. And it currently works for Python. We are trying to get Ruby and perf support, and it can be checked on this link.
We go back to the slide with the diagram right there. So basically, the script agent, I think, is that the Python engine itself?
Yes.
And you actually, is there a code that already gives you the symbols and everything for that, or is that something you had to add, like inside the script agent? So Python is a debugging option you add in Python?
So this is basically a module that you need to say like Python-R and say the name of your Python module, which can be actually the C code, like some Python extender, so it's kind of very fast. And it's getting the callbacks from the Python agent with all the debugging data.
From the C code, that's...
From the C code, yes. From the C code, And so you get all kinds of data, like when the function is called in the Python, when there's executed another line. So by this information, we create the virtual stack that we populate to this memory area, which is shared with kernel.
So you're just more interested in the actual the modules that you add to it, not related to the. So you want to profile the modules that are added onto Python, and not so quite the actual Python virtual machine itself.
Not really. I mean, you load this initial script, which will gives you all the profiling data, but then you say which script you want to execute, and you will get the data from the running script. This agent is flowed on the beginning, just hooking up all the debugging functions, and then you specify the actual script that you want to run, and this will be the script that will be profiled.
So is it actual profiling or it's tracing? I mean, do you take samples?
It takes samples. So far we tested on the basic hardware events like cycles, maybe cache misses, but probably only some portions of the hardware events make sense because there's an underlying interpreter running, and you have always the state, the virtual state. So you kind of need to keep that in mind, that behind this line there's an interpreter. But kind of it could make a sense. So I mean the plan is we will give this to our performance guys that will play with it for a while and see if this is actually useful. And what we plan is to put it for Python. Ruby seems to be doable as well, and maybe perf. So
yeah, I mean, how do you test it? I mean, test that it's actually giving you information that actually makes sense, not just giving you just, hey, this looks good, knowing that it actually is bad. You actually ever write like a script or a module in there and you just put a while loop, like just say, I equals 1 to 10,000 or to 1 million, and just put it someplace to see if the profiler catches it.
Yeah, I think we tested mainly on the YAM, which is like, sure. All right. So YAM is it's a different name now on the Fedora. It's the installation installer, and it's just
DNF.
Yeah, and it's
Do not F with me.
Sorry.
Do not F with me. That's how I remember it.
Yeah, it's just like it's written in Python, so this is what we use so far for testing. It runs a lot of stuff and it can run for a while, so this is what we've been executing this on so far.
Something that I'm thinking about as I see this, one possible eventual integration between LTT-ng UST and perf. So the way you share memory maps between Python and perf, so that memory map could be a LTT-ng UST ring buffer in flight recorder mode, taking flight recorder trace. So you could basically eventually use perf to sample area of time of sequence of events. So let's say you have a 4K buffer, and you sample that 4K buffer, so you'll have 4K worth of events, contiguous events from the buffers, and you could pull that as samples as well. And that might be more applicable in a more general setup.
Well, actually, it's written in a generic way. It's written like that you set up the perf for application to be able to add to the sample any user data that it wants. So basically, you register the data area with PRCT call, and then when there's a perf sample, whenever it sees that this area is registered, it will put it to the sample.
So is it limited to a single mapping, or can it be given multiple mappings? How does it work?
Single mapper at the time, just the memory and the size.
So in order to have efficient user space tracing, you usually want, let's say, one mapping per CPU for NUMA machines and stuff. So perhaps extending it to support multiple mappings might be useful.
Yeah, good.
is there any controversy? I know Peter Zylstra said he didn't care. Was it just like, don't bother me with it, or did he have an issue with it?
Sort of.
Okay, so he just like, don't bother me with this.
Yeah, he said if people want some things to run faster, they wouldn't write it in script, so hence there's no need to profile it, but apparently there's a... I mean, the guys that asked it, in the cloud, we have all sorts of scripting languages, and I'm not sure if there's any reasonable way for profiling them at the moment. I guess there's.
I think it's pretty incorrect to say that you don't write scripts if you want to run stuff fast, because scripting can be used really well to tie things together. So you basically have with math libraries or stuff, and the Python scripting around it is just to tell you what to calculate. And then if you can look at the Python script and do the perf stuff there and see, hey, this part is the block where most of my time is spent, and then you can look at the underlying math part and improve that. So I think it's pretty important actually to do the performance measurements with Python as well, with scripting language in general.
Right. So by the way, just to ask, does it only profile, you said, the stuff that's in C then, or is it, if you write if you write something in Python, okay, you're talking about you compile it into the C code part of it, or and then pull it in, or is it? I'm a little bit curious when you said it pulls in the Python library, because I know you can write in Python and then it gets compiled. I guess like you could kind of. Yeah. What were you talking about? Which part? Because I know you can also write a C plugin, and.
Oh, so I was talking about the script agent, which is actually so this is this initial Python module.
So that's like in C that you attach to Python.
And yeah, it is the Python extension.
Okay.
And it's C code, and it's getting the hooks from the Python itself. Right?
So then here, this is like showing you actually the Python code. What's where the problem is? Which function or def function the Python has that's causing the most problem? Is that what you're saying? Back to the output.
Yeah, the output is the Python functions.
Yeah, those are all Python functions.
Mm-hmm. Yes.
Okay, so, or that's, it's just telling you that's a symbol that sits in run. So this might actually help you find places that you might want to try. Take it, this function is really, really slow, but maybe if I could convert it to a C function, then make it a plugin for Python, we can speed it up.
Yeah.
Have fun.
So basically, you see any sense in doing this? I mean, because I've got a lot of different feedbacks. Somebody says yes, somebody says no.
Or I don't care.
I don't care.
I mean, it's not everyone who starts writing things from scratch in a compiled language. I mean, in prototyping, it might make sense to start by writing scripts and then optimize the very important code, but you need tools to be able to identify what actually matters. So it does make sense. So, right.
Any other questions, sir?
But if you actually run Python to see compiler, there are some versions of Python that will actually compile to C, and then you'll have the debugging information, and then normal profiling will work. So keeping Python could be working with a different runtime environment.
Yeah. As I said, this is just a prototype. We are basically devising the way to work for many other languages, like many. Python was it's actually easy to hook and stuff, so it was the first choice.
Okay, just to get what I think the question you're asking, if Red Hat finishes this project, usually does it all the work, it gets working, raise of hands of who would use it. There, I think that's your answer.
Yeah.
Done? Thank you.
Thank you.